Okay, hi, my name is Blake Crosley, and I'm going to show you the two models that I use for body fat and the two that I use for heart disease. So, jumping right into it, I used a linear model for my first model for body fat, and this was just to see how well it could predict body fat based on the 15 variables or 14, not including the body fat percentage. So yeah, let's go ahead and run this model here, and then we'll go ahead and get a summary of it. So as you can see here with the R squared, that kind of just shows how well the model fits it. And so with the 97.8% of the variance in the body fat percentage can be explained by the predictors in the model. So that shows that it was basically 97% of the body fat percentages could have been predicted by the computer. And this was just a great model to show that the computer was able to predict relatively accurately the body fats. So my next model that I ran was a tree model. And so we just ran that model there. And the reason I chose a tree model was I thought it could show how if a variable is above a certain number, it could kind of predict if the body fat would be over a certain percentage. So we'll just go ahead and show that plot there. So there's the plot that it came up with. So that's basically what I got for the body fat database. So for the heart disease database, it took a little bit more effort to kind of get the models to do what I wanted them to do. So I created a way to clean it up with the training data and evaluation data. So we'll go ahead and run those two lines of code there. We'll also make sure that our part is selected in our packages. So for the first model that I wanted to do another tree model. I felt like this was fitting given that either you have heart disease or you don't have heart disease. So I thought it would be a good way to look at the data and see if certain variables cause you to A, have heart disease, or B, not have heart disease. Because when we look at this, looking at, sex plays a big part of this, age, exercising, and obviously cholesterol and things like that. We wanted to see if having that or not doing that made you have heart disease or not. So when we go ahead and run this for the tree model, go ahead and get this table right here. Just kind of shows the accuracy there. We'll go ahead and run a confusion matrix as well. So the accuracy is 87.5%, which is relatively well. I don't think it's anything outstanding, but it will kind of semi-accurately predict predict heart disease if you have it or not. So we'll go ahead and plot this tree model as well, just to kind of show how it worked. It looked at cholesterol, chest pain, sex, and exercise too. So the next model I decided to do was a logistic model. It was just another way of looking at the data. So we'll go ahead and run this. Kind of came up with this table, which is very similar to the table that we had, or it's actually the exact same validation predict table. We'll run a confusion matrix for this as well. And as you can see, it is the exact same output as the tree model. So I think it would be beneficial for either one of these models to be ran on this type of data. So also just go ahead and run those types of codes too. So overall, the heart disease I thought was a little bit harder to predict. But yeah, using a tree model and logistics model was the best way I could come up with trying to get the computer to predict if you would have heart disease or not have heart disease. Thank you.